Okay, anytime we want to do filtration, we've talked about tools that we can use like prefix lists, access lists, standard and extended. But the problem with all of those solutions is that if we lose a link in our infrastructure, we're not going to be learning any of the prefixes that we can use for high availability or alternate reachability. Now, inside of our current line of reasoning, we're going to start moving to tools that are going to allow us to do traffic engineering or filtration based on metric. Now, the idea here is going to be very similar to where we were going through and doing things like with the delay. Now, I mentioned in the previous video that EIGRP uses hop count, and we were talking about offset lists, and that's what this particular video is going to be about, is the use of offset lists to be able to manipulate EIGRP's routing decisions. But we used offsets previously with the concept of our RIP traffic, which uses hop count. EIGRP does have a hop count. It's going to be 100 by default, but when we start manipulating using offset lists, what happens is we're actually manipulating the metric. So the composite metric, we're going to be adding particular values to it. And it's going to be the most straightforward method for us to be able to do manipulations. Now, what I want to do is I'm going to focus on a two-way scenario. We're going to start first with scenario 1. Scenario 1 is going to say prefixes on R22 need to be advertised such that R1 will use R3 to be able to reach traffic. So what that's going to say is I want R1 to use this path right here to reach any prefixes or a prefix that we're going to experiment. Let's say we'll use 7.2.16.222.0/24. That'll be the network that we're going to play with, that we're going to originate on R22. Now, the way that I'm going to do that is I have different capacities. So when I start looking at this from the point of view of R1 right now, if I've got everything configured properly, should load balance to reach that destination. So let's take a look and see what we got here. Show IP route 172.16.222.0. And there we go. So we'll trace route to it. So trace route to 172.16.222.222. And I'm load sharing. Notice I'm going through Cat 2 and Cat 1. All right, now what I want to do is I want to manipulate this decision such that R1 is going to use the path through R3. Now, the way I'm going to do that is I'm going to use offset, and I'm going to increase the metric that I advertise out of R22 on serial 2/0. So let's take a look at exactly what that form's going to be. Now, what I'm going to do is I want to, first of all, match a prefix. I don't want this to be for everything. So what I'm going to say here is, well, let's go ahead and look at it. Let's take a look at what's going on here. So if I say R22, so if I go to R22, and I go to my routing process, router, EIGRP 10, and I say offset list, what we need to understand here is if I say 0, or if I create an offset list that calls an access list that doesn't exist, it's going to match all networks. So what I'll do, let's see what I've got here. Let's say do show run section access dash list. Nothing configured. So we'll go ahead and say we're going to match on 1. So I'll say distribute list, I'm sorry, not distribute list, offset list, 1, permit, and what do I want to permit? Actually, I'm sorry, I'm going to create the access list first. So access dash list 1, permit, and I want to permit 172.16.222.0. Now we'll go to the routing process, router EIGRP 10, and here I'm going to say offset list. Oh, doggone it. I was trying to do it the wrong way, or the right way, and I was trying to illustrate how I'm going to do it the wrong way. So I'm going to remove that access list. Sorry about that. Router EIGRP 10 offset list, and I'm going to call an offset list that doesn't exist. I just deleted it. And I'm going to say out, and what I'm going to do is I'm going to add an offset. So let's say that's 1, 2, 3. So it's 20, that's 2 million, right? Yeah, 2 million. So let's add 1 million to this. Out. do show access dash list. All right, now let's take a look at what's going on R1. Remember, when we did it before, we were doing our load sharing. Well, according to this, we're still load sharing, but let's wait and see what happens. Okay, now we resynced. Now remember, this is something that we need to wait for. Now let's see what ends up happening. Okay, we're still load sharing. So the question now is what's going on? Well, we're not load balancing like I would originally or initially think that I would be doing. So let's look at this. So the question now becomes, what are the feasible distances that I'm learning for the prefixes that I'm applying to my routing table on R1? How can I do that? Let's take a look at show IP EIGRP topology, and I want to look specifically for 172.16.222.0/24. And what we see is I have two entries, and what we're going to look at here is what I want to point out is the fact, if I can get my feasible distances all to appear on the screen, my feasible distance all match. So that's interesting. So the question was, or the statement was, let's see if we got our configs properly done. So do show run section router. I added 1,000,000 to it outbound. So let's take a look and see what's going on here. But notice I added 1,000,000 in every direction. That's not what we want to do. So when we start looking at this, we need to make a modification. Now the modification is that I wanted to advertise this to R2 because I want to use R3 for my reachability. So let's get that in place. So all we did is we just did it to where everything now matches. So all I'm going to do is I'm going to say, and I'm going to specify that I want to do it out serial to 0. Do show run section router, and let's see what's going on. And here's the danger. The danger is it didn't remove the old one. So let's go ahead and take it out. So no offset list 100. Now let's take a look and see what's going on. Do show run section router, and we see here that we have the original one that or the one that we want, not the original one. So now let's see what happens. We have resynced. Now let's go over to R2 and see what's going on in our topology. Let's repeat our topology config. So we're looking at the topology table for this specific prefix, and let's see what we have going on here. Well, let's see, we've got 2, 1, so it's 3. So we've got 2,129,047,318, and here we have 2,194,000. I'm sorry, nope, that's not right either. So yeah, 2,194,583,318. So we are only going to pick one of these prefixes to place in our routing table. And it's going to be the lowest. And what we're going to see here is, remember, we're using that divide by 12 that we discussed, because remember, this is a named mode device. Let me pick a better pen color, a better pen. This is a named device. So we're using EIGRP named. So what we're going to do is we're going to be taking that and dividing this value right here by default using 128, and it's going to produce this value, which is going to fit in our 32-bit fields in our routing information base. So now if I come up here and do my trace route, let's see what happens. So let's do a trace route to that prefix. Now what we're doing is we're going through the devices that we wanted to go through. We just went through R1 to Cat2, from Cat2 to R3, from R3 down to R2. So we're following the path that we want to take. But let's look at this. What happens if I ping another, or I look at this from the point of view of another prefix? So what happens if I ping, see, 223? Is that one of my interfaces? Yes, it is. Well, notice it's going through R12. Well, let's see here. Show IP interface brief, E assigned. Okay, I'm pinging the wrong address. So let's go back over to R1 and end this, and I need to ping 223.222. And notice I'm still going through R2. Now the issue here is, if we go back to R2 and we take a look, R22, show access list. Well, I don't have an access list. So what's happening is a show run section router, I'm actually sending every prefix that I'm advertising out of serial 2/0. I am going to be sending it with an offset metric of 1 million added to the composite. Now we only wanted to do this on networks that corresponded to 172.16.222.0/24. Let's go ahead and make that modification. Well, we already have an access list. It's just an access list that's empty. Config T do show access dash list. And what we see here is there's nothing in there. So let's go ahead and create one. So access dash list 1 permit. And what do I want to permit? I want to permit the network 172.16.222.0. And I'm going to go ahead and add an explicit deny just so that I can see the filtration on it. So it's going to be deny any. All right, now let's wait for it and see what happens. It should resync. We made a change to an access list that's applied to a EIGRP process, and let's see what goes on. There we go. It just resynced. Why? Interface route configuration changed. So now let's go over and take a look at what we're learning on R1. So first and foremost, what happens when I try to go to 172.16.222.222? Hit enter, and I'm going to be going through Cat1 up to R3, up to or down to R22 as my final destination. What happens with 23? Notice now I'm load sharing. So you've seen how we can use either a 0 or an access list that doesn't have a configured access list to match all of the networks that I want to be able to advertise. Or I can also use it by specifying the access list using just a regular access list that I'm going to be configuring like a standard access list in order to be able to pick the prefix that I want to add the offset to. So with that being said, that pretty much wraps up how we can use the offset list. And later on, we'll explore the idea of the hop count, because again, you're going to need to understand that we can use hop count for the purposes of filtration. But, oh, actually, there's another element that I want to bring into play here, and that's the fact that all we did was change the metric. So let's go back to the topology, and what I'm going to do is I'm going to go into R22 and shut down the interface, and what we're going to see is we're going to have reachability maintained. So let's go to R22, config T, interface, S21, do show CDP neighbors. It's going to tell me that 2.1 points to R3. That's the path of choice. So what I'm going to do is I'm going to shut that down. But now by virtue of the fact that all we did was modify the metric that's being modified via the offset list, R1 should immediately be able to put its entry that it had in the routing table for 223.222, and now what we're going to do is we're going to be able to go through R3 for 223.222, which would have normally been load shared, and we're going to go through R3, which would have normally been sent, I'm sorry, we're going to go through R2, which would, no, let's see here, hold on one second, what did I do? 222, we've got 11, so it's going through R1. That doesn't make sense. Hold on one second here. So R1 is going to 11. Oh, we got a wrong IP address. It's going up to R2, then it's making its way. So it's actually taking the path that we want it to take. It's taking this path right here up to R3 via Cat1 or SW1. And the problem here is that for some reason looks like R2 is returning a .3. So let me look at that real quick. So let's go over to R2 and let's take a look at that interface. Do show IP interface brief, E assigned, and that's why. the address here. Let me fix that. So interface E03, IP address 10.1.210.255.255.255.0. All right, now let's go back over to R1 and repeat that trace route. And now it's using the right address. All that was just a misconfiguration on my part. Between one of the videos, I actually had to redo my topology, and it required me to reapply the addresses. Obviously, I fat-fingered it. But the idea here is that keep in mind, by shutting down an interface, since we're doing a metric manipulation, we are going to make certain that we can actually have high availability where we can have a prefix that can either be entered through a dual computation, or if the metric wasn't increased to the point to where it was going to be dropped out of the topology table, if it's in the topology table, we can just switch over to it immediately. So with that being said, that's a pretty good illustration of how we can use offset. And like I said, we'll look at the idea of hop count for filtration in the very near future. So what I'm going to do right now is I'm going to move over and we're going to talk about how to do filtration using administrative distance. I'll see you guys in that part of the instruction. Bye-bye.